Now let's turn our attention to the machine learning workflow. This slide gives us a high-level overview. We have a series of steps that are crucial for building and using any machine learning model. Let's walk through each one. First, we have data extraction. This is where we gather the raw materials for our model, the data itself. Think of it like mining for valuable information. We need to collect relevant data from various sources, databases, files, APIs, and so on. Raw data is rarely perfect. It often contains errors, missing values, inconsistencies, and noise. Data cleaning is the process of identifying and correcting these issues to ensure the quality of our data. This might involve handling missing values, correcting typos, standardizing formats, removing duplicates, and dealing with outliers. Train-test split is a fundamental concept in machine learning. It involves dividing a dataset into two parts, a training set and a testing set. Train-test split helps evaluate how well a model performs on new, unseen data. The dataset is typically split into 70-80% for training and 20-30% for testing. The model learns from the training set, and the trained model is then tested on the unseen test set to assess its performance. In the model training phase, we feed the training data to our chosen machine learning algorithm. The algorithm analyzes the data, identifies patterns, and learns to make predictions or classifications based on those patterns. After training, we need to evaluate how good our trained model actually is. We use the separate testing dataset we created earlier. We take the testing dataset, check what the model predicts, and compare the predictions against the actual values. This step helps us understand the model's performance and identify any weaknesses. During model training, we choose a specific machine learning algorithm, like maybe a random forest or neural network. These algorithms have internal settings called parameters. These parameters control how the algorithm learns. Parameter tuning is the process of experimenting with different values for these parameters to find the best configuration for our specific problem. We use these results from model evaluation to guide our parameter tuning, trying different settings and reevaluating until we achieve satisfactory performance. It's often an iterative process within the model training and evaluation loop. So we've trained our model, we've evaluated it, and we've fine-tuned it to perform well. The next crucial stage is model deployment. This is where we put our model into the real world to actually do something useful. Model deployment is the process of making our trained machine learning model accessible and ready to be used in applications, systems, or processes to make predictions or decisions on new unseen data. Once our model is in deployment, it's now interacting with real data. This data might not be exactly the same as the data we used for training. The world evolves. Data patterns can shift. We call this data drift or concept drift. Data drift describes changes in the data distribution. Concept drift describes changes in the relationships between input and target variables. Model monitoring is our way of detecting these shifts and their impact on our model's accuracy. We track key metrics, analyze the input data to see if it's changed significantly, and look for signs that our model is becoming less reliable. Model monitoring helps us catch these issues earlier so we can take action and maintain the value of our deployed model. Machine learning workflow is a cycle, not a one-time process. We don't just go through these steps once and consider it finished. Machine learning is about continuous improvement and adaptation. The real world is dynamic. Data evolves and model performance can drift over time. This cyclical workflow allows us to continuously learn, refine, and maintain our models, ensuring they remain effective and valuable in the long run.